Hello and welcome to Notes 2020. Thank you for joining us today. I'm Aris from CTJS Conference. CTJS Conference, a community conference, is a JavaScript festival across London and the world, a joint event from London JavaScript meetups. This is a fantastic opportunity for the JavaScript community and for those aiming to stay in touch with the industry, to be updated on innovative changes around the industry and the JS as an entity. I would like to introduce you to our speaker, Uday Korlimarla, a founder at Inspector, who will be presenting on Unlock Cybersecurity with Knowledge Graphs. To give you some background on our speaker, he lives in Melbourne, Australia, and he loves React, JavaScript, GraphQL, and Neo4j. With his love for application security, he's on full sail ahead with his startup Inspector. Thank you and welcome, Uday.
Hi all, I'm Uday Korlimarla, and today we're talking about security knowledge graphs, or how do we build our security knowledge graphs. And before we go ahead into the talk itself, a quick few things about me. I live in Melbourne, Australia. I'm the founder and CTO of Inspector. What I pretty much love is React, JavaScript, Python, and everything application security. I have a master's in cybersec from the University of Nebraska at Omaha. And there are a few things that I really strongly believe, and two of them, at least one most important, the most important one of them is that apps are pretty much deeply part of our lives, both professional and personal lives. So securing apps is pretty much important to all of us for our own collective interests. Now, just a brief introduction about Inspector. It's an Australian cybersecurity startup. We have a cool mascot, or at least that I think that it is cool. And Neo4j is pretty much at the core. It's the core of our product. Our Grand Stack is what plays a very important role in our startup. We have a Neo4j database set up with GraphQL and all a React application which uses all the data and relationships. So pretty much a Neo4j stack in a way. And we are in the business of creating security graphs to help developer and security collaboration, and to help make security measurable. Now, quickly about the agenda today. So one, of course, is to acknowledge that we have apps everywhere in our personal lives and professional lives. And to quickly talk about knowledge, which is the newer currency, and which is pretty much the idea behind building knowledge graphs, security knowledge graphs today. And also a brief application security primer, or just a quick conversation about what is application security in our context, and talk about OWASP ASVS, or the Open Web Application Security Verification Standard. It's a really big acronym, but that is our dataset. So the OWASP ASVS is pretty much our dataset. And I'll follow that along with why Grand Stack, and why Grand Stack means something to me, or why Grand Stack means should mean something to you if you're using Neo4j. And pretty much the hidden agenda is to just share this, that let's make CSV great again. All right. So quick disclaimers, I'm still very new to Neo4j and graphs. I believe graphs are awesome. This is not an endorsement to either OWASP or Neo4j. This is just a very generic talk on how I am using Neo4j and Grand Stack to construct my own security knowledge graphs. And all opinion and information shared are personal. Now, before I run ahead into the talk itself, a quick note about graph databases. So think of graph databases as a way where you can store information and query for information back, but in the most human possible way, or very close to human relationship model. So we correlate our things like, hey, this person is my friend, this person is someone I do not like with. We have this sort of relationship when we're talking about people. Or for instance, Uday likes burgers. So the relationship there is me and burgers with the relationship being like. So there is a relationship which is very natural for us to perceive, and graph databases help us accomplish this. I have some links in these slides which you could later visit and read if you're new to Neo4j or graph databases. So now that we have talked about what graph databases are, quick note on knowledge graphs. So this is some information that I've pretty much borrowed from a Google search. So if imagine you take any ontology and you acquire that information, and then you derive some knowledge, or you are able to apply some reasoning on top of this knowledge, you could call it as a knowledge graph. And I do agree with this definition, personally at least. So in my definition here, security knowledge graph would be an ontology that belongs to the cyberspace, cyber domain, where the intent is to discover some sort of a hidden relationship. And I'd be limiting the conversation of this talk to just application security, uh, because that is pretty much my bread and butter, I would say, or probably, we don't have too much time. 45 minutes is quite a lot. Thank you for the time. So a quick note on apps. We have apps everywhere in our lives. We use apps for playing games, Minecraft, Candy Crush, to talk with friends and family. We have apps like WhatsApp, Facebook, Telegram, you name it. Netflix for watching new movies or TV series. And also we have apps like Instagram and Spotify to listen to music or share some for memories with people who are across the globe. And it helps us be connected with the world in a different way than how it used to be. So it's a new digital world. It's the transition didn't happen just at the flick of a button. It did take some time, but the reality is that today apps are pretty much part of our lives, and apps run everything, like for us to get from destination A to destination B and so on and so forth. Now, so what these apps are made of is software, and these software help us basically to order food, watch silly cat videos on the internet, maybe share memes with your friends and family, send money to people if that is what you're into, or even learn and grow as a human being. You have the opportunity to learn new things. For instance, you could just buy a book on Amazon Kindle and get started with reading the book right away, whereas this wouldn't have otherwise been possible if we were without an app like, say, Kindle in this instance, to start reading a book digitally. But software has this inherent characteristic to it, which is software is malleable. It tends to change very quickly. The evolution is really fast, and software has flaws. We have to acknowledge that software has some flaws at some points, and that's why it continues to keep changing and evolving. So that makes it malleable. Now, some of these flaws that software, any piece of software can have, might also be a flaw that a malicious actor can take advantage of. So when a malicious actor takes advantage of the flaw, it becomes a hacking incident, maybe disrupting businesses and impacting people and livelihood, basically. So it is important for us to find these flaws which are related to security and fix them out earlier, to make sure that we have a secure app, if I should say. So in order to verify if your application is secure or not, you need to establish some sort of a smarter criteria. And it's not so easy to do this at an organization where, say, if it is a small startup like me, we might not probably have much of a time and luxury to sit down onto application security. Rather, our focus might be onto solving the main business driver or business problem, or generating some source of money for the company to sustain. So what one can do is create a verification checklist, and these checklists needs to meet a certain criteria. These checklists need to be smart. And we are pretty much in the age of wisdom. Basically, we take some data, we convert that into a knowledge base, and we have to derive wisdom. And that is the idea behind the talk as well. How can you take data source and convert it to some sort of information and then derive some knowledge And then ultimate goal is to convert this knowledge into wisdom. Now, a quick acknowledgement on the term OWASP. If you have heard of OWASP in the past, uh, Open Web Application Security Project is pretty much the epitome for application security. The most common reference that people may have come across might be for OWASP Top 10. And the data set that we're looking at today is OWASP ASVS, the Application Security Verification Standard. It's pretty much a CSV file that is split across 14 different domains in security so that you can start examining where is your application in terms of security. And this is the smart criteria that helps us um, establish how to measure the application security for your application, basically. Now, going a bit more into OWASP ASVS, and the a few of the slides that I borrowed are from a talk, India's Oslo 2018 by Alexander. I would encourage you to go ahead and visit his talk, which is available on YouTube. And if you're interested in reading about OWASP ASVs, I have a link in the slides which will take you to reading more about OWASP ASVs, the Application Security Verification Standard itself. Now, quickly touching on the SMART criteria, your SMART criteria is something that is very specific. It is very, very clear to understand what you're trying to do, what you're trying to verify. It needs to be measurable and achievable, relevant, and time limited. So you can try to build the most secure app, but at the expense of time. So you always have to time box saying, okay, this is the limited time I have. What can I achieve? And what should I be achieving? How can I measure this? Is it relevant to my business? And that's pretty much the SMART criteria, at least in my personal opinion here. And what ASVS has is 4 different levels. 0 is where your application is not connected to any network, or hopefully is not connected to any sort of network. 1 is where you're on the network, maybe internet, or maybe inside your organization, or just at your home, and you want to do some sort of basic security. The level 2 is where you're really interested in improving the application security or measuring the application security. And 3 is where you're a business application that processes, say, potentially uh, personally identifiable information, financial information, or any data that is deemed as sensitive or needs protection. So this is how the stages go: 0, 1, 2, and 3. We are not going to look much more into the levels today because this is not a talk on ASVS, but it's rather a talk on ASVS graph, or the security knowledge graphs that we're building out of ASVS. So what we are interested in is the 14 domains that are available in ASVS. We are not going to touch base on anything that is related to industry standards like PCI DSS or maybe even OS Top 10, but we'll be limiting ourselves just to these 14 domains. Now, harsh reality of any checklist is, here is one item from ASVS, and this is how it would look like. So here is a specific industry, here is a threat profile, L1 are the level 1 requirements, level 2 requirements, level 3 requirements. So this is the harsh reality, and ASVS has much more than one item in the checklist, right? So what ASVS has today is roughly 285 items to verify, and imagine the level 1, level 2, level 3 that you have to do in order to make sure that you have completed the whole verification criteria. Now, this criteria has been built by several thousand people contributing to an open source project in their own free time just to help uh, make security more accessible. So obviously they're interested. But at the same time, when we look at it from the lens of, hey, I'm a developer, or hey, I'm new to security, 285 items to verify for a level 3 is still quite a lot for an organization just to meet compliance or just to measure security. Now, that's a little daunting exercise. And we have a smarter criteria. We have ASVS that is giving out all these smarter criteria. But I have a different inspiration, which is from the OWASP cheat sheet series. Life is short, AppSec is tough, so let us cheat, and we'll be using our security knowledge graphs to construct some amount of cheat here. Now, The security knowledge graph, what I do here is I create the verification items into Neo4j database. I establish some relationships with the goal of reducing these 285 into much little lesser or having more meaning between these 285 verification items. The first discovery I made was, hey, there are 285 or 286 items, but they have at least 332 relationships just with one specific identifier. Now, for people who are new to Grant Stack, it's basically Neo4j, GraphQL, Apollo server, and your React application. I have my GraphQL schema put up here. It's actually a very simple schema. You have a stage to describe what stage that you're in, like or the security domain. For instance, architecture, for instance, cryptography, or anything of that sort. Now, what I'm interested in looking at is the CWE identifier, or the common weakness enumeration identifier from NIST and MITRE. This basically is the software fault, software flaw that is related to security, and is a small subset of software flaws in general. Final. So in order to get started, the first steps for me is obviously to go through Neo4j database, do some seeding, and run my GraphQL server up, and then do the seeding so that I have the database with all the verification labels or the Neo4j nodes available. Once these are available, the obvious next step would be for me to start seeding the database. So what I would do here is I could follow this link. There are some instructions that you could follow along. There is a .env file and a env sample file, which you should be renaming when you're using this project. And this would pretty much contain your Neo4j credentials, username, password, the Bolt URL, if you want to use an encrypted connection or not, and the default database name, pretty much relevant to Neo4j 4.x and above. Now also I have a markdown file without any much description, which is a bunch of Neo4j relationships that I'll be adding between nodes. So that is something that I would need. So let's go ahead with the seeding process. So I have my GraphQL server up, that looks good. And I'll go ahead to my Neo4j database, and it is up and running as well. So I'll go ahead and seed the database, and fingers crossed that everything works. Give it a few seconds and we should be able to see some data. All right, so it looks like we do have some data. The obvious next one is for me to see what those nodes are going to look like. So I'm going to say match AWS return a limit 10. I'll just go with 10 nodes first and see that I do have 10 nodes. There is no relationship here yet, and I do want to definitely establish some relationship here. So what I'll do here is go back to the relations markdown file on GitHub for the project. Open this as raw so that I can copy all this text and not have any copy paste issues. Go back to my Neo4j browser, paste in these relationships and give it a few seconds, and fingers crossed, hopefully the relationships will start kicking in. I can see that some of the relationships have started to kick in. Looks good, feels good so far. All right, cool. So now I have all these relationships in. What I have is a quick cheat. I'm going back to the repository again. And this time I want to search for something. So I'm going ahead to my GraphQL schema to copy paste a search that I want to perform. Now, this is pretty much the core of our searches. And I'll explain what I'm going to search for in a moment here. So what I've just pasted is a query saying, hey, the data set or the nodes ASVs, I want to get relationship where something is of stage architecture or the security domain architecture. where the relationship is coming from ASVS, where you want to verify for cryptography. Now, for people who are unfamiliar with ASVS, the way ASVS is listed out is as 14 domains. One of them is architecture as a domain of the 14, and cryptography is another stage. So in my case, I'm saying, hey, anything in ASVS after I've established relationships, if there is a relationship that is uh, to verify cryptography or something that is related to the verification of cryptography, and is relevant or present in the architecture stage, give me those results back. And I hit my search and I see some information here. Now I do not see the relationship between these nodes. So what I want to do here is I just don't want to return anything that is the architecture stage. Rather, I want to get the whole shebang. So let me go ahead with that. Now I see that, hey, there is one item that belongs to cryptography, which has 4 different items that is um, related to architecture, or keeping it short that way. Yeah, so we have one item that is verification of key material that is not present. I can't read the whole description here, obviously, but the intent is to see that I have some sort of relationship. So the other way around on how this would have otherwise looked is we would have had 48 different items in architecture, and one of them would have been cryptography. So what we have just done is we have taken this flat file text data set, the ASVS checklist, and we have created some sort of a formal relationship saying, hey, if you're verifying cryptography, look at this item, or if you're anything but cryptography, but you want to verify it in a stage that is architecture, here is the relationship. So we have established some sort of a formal relationship. And this basically makes my life easier as a security architect, maybe, or as a software developer. I can borrow on these relationships to say, okay, what did I do for cryptography? Where did I do it? How is it related to other items? Now, this is a very small subset of the data that we have looked at so far. So what I would do here is I'm quickly going to remove all of the verification relationships that I was previously looking at, and just enter something in here and see how things come out. Now, obviously, we can see that from here, not all nodes are strongly connected. And there is a specific reason behind this. That is because software security is not going to be the same as, say, for instance, how you'd look at your network, how everything in your network is connected. So obviously, software security and their domains are not so strongly connected because of the specific activities and specific requirements that are put in. So it's kind of a disjoint set. It was a very disjoint set, and what we have done is convert that disjoint set into something that is very strongly related, or at to some degree has some sort of relationship here, which makes sense. Otherwise, it would have just been 280 items. But if I show this graph to someone, they, it might pique their interest, saying, okay, it's not too bad. It's like, just a few nodes that are connected to each other. So it's a bit more positive approach in a way. So potentially you could use this as a collaboration tool with developers if you're talking with them. And yeah, so that's one from the Neo4j side. So now what I'll go ahead is open up Visual Studio Code here, expand my code base for the GraphQL. And here's my schema. And obviously it is very flat. If you visit grandstack.io, you would see that you could do a lot more than just have this simple schema. You can establish relationships between different types. But what I'm doing here is I have a very simple type, which is from the CSV file dataset that I have. And that dataset, you can look at this dataset if you visit ASVS, never mind me there. But I have a flat file that is here. So here is the flat file, the CSV file, and we have just converted that flat file into a Neo4j nodes and relationship kind of a model. Now, further, what I can do is I can use GraphQL to query for the same data that is on Neo4j, and that let's go ahead and do that. Let me navigate to my browser, navigate to the GraphQL playground. And I'm already connected to my GraphQL here, so I'll write a query. I want to query for, excuse me, query ASVS and get me serial, get me the stage or the security domain, and also get me the CWE identifier. So let's go ahead and run this query. And I see that there are a bunch of nulls coming up. This is pretty much the reason why all the nodes are not connected, or there is not yet a strong relationship between all these nodes, because each serial number is designated by a single identifier, the software security fault pattern, basically, or CWEs. And I can see a bunch of information here. Obviously, if I want to read more, I could even add description and get all of this information. Now, what's happening here is this GraphQL server is talking to my Neo4j database here, and here's a Neo4j database browser. Now, obviously, it's not really helpful if I just search for the same data set again in the same way, right? If I just search for ASVS data set and I get information as flat text, I'm no good other than how it is with a CSV file. I might be better off with just using the CSV file. So our obvious intent is to add some value to the CSV file. And what I've created here is a query called get architecture crypto, and a subsequent other query called get crypto architecture, where I'm looking at a two-way relationship between architecture phase of your software development to cryptography verification requirements. So this is the other way around, where architecture says something about cryptography. So we are looking at a two-way relationship here and getting information back that is relevant to us. So in the first case, I'm related to everything that is in architecture, but related to cryptography, and I get back the results that are related to architecture. And in the other one, I would get back the results from cryptography related items. So from what we saw in our nodes previously is that there are 4 nodes on the outer edges, and there is 1 node on the inner edge here. So we would only be dealing with 5 items, I guess. So let's go ahead back to the GraphQL playground and change this query to get architecture crypto. And I would like to get the stage serial and CWE ID, and I'll leave the description aside for now. Now, before I run the query, I can quickly see that I have a bunch of items, or pretty much all the 285, 286 items that I have seeded into the database just as ASVS without any relationship. Now, this is where I'm leveraging this relationship to give me very specific data. Give me anything that is in architecture but related to cryptography. And I do the search. Oops. So we have a small problem here that we should go ahead and fix. So let me take this query again to make sure that yeah, so everything looks good. So I'm querying for everything of the type ASVS. I should get multiple items back here. I'll copy this query into the Neo4j browser. Okay, that looks good. So I get just specifically 4 items. And okay, so this might be related to fixing my APOC, so install an APOC library. Let me see if I can do that locally. And all right, so this might mean I may have to restart the database, and fingers crossed here. I'm not sure if this version is compatible. Well, either way, fingers crossed. probably give this a few seconds and we'll keep that running. So in the meanwhile, while I wait for the database to be ready, what I'll walk you through is the React application that I have. The React, GraphQL, and Neo4j completes my grand stack. I don't have much here on the actual web application, but what I'm interested in is looking at how or what I see information here with under the stage. Give it a second here as well. I think this is probably because the database is down, I guess, and I shouldn't be able to see anything until the database is back up. So we'll wait for a database if that makes any sense. All right, so it looks like our database is back up and running, and I'll run this query again quickly to quickly check if everything works. And now, given that given APAP is now available, let me go ahead and restart the GraphQL server and see if everything works fine there. So everything looks okay. I'm back to my GraphQL playground, and hopefully I should be able to make this query work and happen. Cool. So now I get just these 4 items, just these 4 relevant items. This is pretty much the information that I see here in the graph as well in the Neo4j browser. And this is pretty much the information that I want to say put up here. So let me reload my ASVS graph. And I can see that I have 42 different items that come towards the architecture. And I'm not really interested in looking at all these 42 items. Say, potentially we have an imaginary search button which says, hey, get me just crypto stuff. And we should be able to just get that crypto stuff. So what I'll go ahead and do now is I'll just copy this query name and make really simple changes to the actual React application. So if I remember where I should be going to, and I think I need to change the query. The query looks about right. Okay, so I've pre-built a query called query 1 and query 2. They look very, very similar. The only difference is here I'm just calling the new GraphQL query that I've written out. So let me go ahead and see where I'm calling my GraphQL API using React hooks. And I'll switch that from being query 2 to query 1, and fingers crossed. If I go back to the React application now and maybe reload the page, everything should be just the cryptography results that I'm interested in. All right, so this is pretty much line 240, and the bug here is because I'm looking for the wrong type of information from GraphQL, and that's pretty much the reason why I copied the text ahead of time just to copy paste it back here. And now we see just the 4 pieces of information in architecture verification stage of ASVS that are related to cryptography. So obviously this is a very basic application, but imagine if you're able to add a lot more information into your web application, the React application, to query and search or filter for very specific information, saying that, hey, is architecture related to authentication, or is authentication verification that I'm doing, is it part of the architecture phase, or is authentication related to cryptography? Who would have thought, right? Well, it should be, it is, but this relationship model is what is the primary objective. We have basically taken the security ontology, ASPS, and we have added some information, some relationships, saying architecture relates to something and cryptography relates or accounts to something, so on and so forth. So let me quickly dive back into the database and rerun with a different query to see what type of relationships that we're getting. And yeah, my cipher looks good. I run a search. All right. So we have verification of configuration, and I want to give verification of malicious content to color, bright color. Now, verification validation is where someone is interested in doing input validation. I would give this a green color just for the time being. There we go. And cryptography, give it more pronounced color or very dull color here. So yeah, so I've just given color for 4 domains so far. And I can see that sometimes nodes can have multiple relationship here. For instance, something is related to verification of TLS or HTTPS, you could say, and that is part of verification of communications as well as verification of architecture. And also there is some connection, some one or second degree of connection here to verification of data itself. So communication and data go hand in hand, which is pretty much how we understand the data, or how we understand the world in general. And it now adds more value and sense that ASVS is security ontology that has smart criteria, because with me just creating some silly relationships based on CW identifiers, I can actually uh, gain more insight into the nodes and the relationships or the actual verification um, standard serial numbers as well here, and across different stages to see and understand the intent of the people who contributed to ASVS here. Not to say that this is to mind reading, but it helps me give me an understanding on what people are trying to think and portray overall by giving out checklists like ASVS. So what we have done is we have added relationships, and then we have explored the data, and we have surfaced all of that information back onto the React application. The possibilities are pretty much limitless. So you could take these application security verifications and build out your own React application and scale it out in a way that is probably fit for your organization or fit for your own professional needs, maybe, right? And the intent of this whole talk is to show you that, hey, I've taken a small checklist, which is 285 items, and I've added some relationships to make my life easier. So as a security architect, maybe, or as someone who's building out security knowledge graphs for as a business or as a startup today, I see that there is a bigger possibility just because I've chosen Grand Stack to help me solve these complex problems. And it is quite obvious to all of us that ASVS is only one ontology, and there are several ontologies that are available that relate to application security. Something like CVEs, something like application has been scanned by a specific tool, say for instance checkmarks or SonarQube or whatever you use, right? So all of this information can come in and add more value to the ontology, and these are things that I personally tick me and motivate me. Now finally, I thank you very much for taking time to listen to me, and I appreciate the uh, time that you've put in, especially given that all of us have to sit at home, and hopefully you're all staying fine while you're listening to this.